Hey guys, how are you? I'm great. So welcome to Maths Recovery with Rebecca. That is me. Today we're going to be looking at trig equations, the different types which I'll be doing in other videos, and how to recognize them. What information you need to know to be able to even start trig equations. And that's what today is all about. We're going to be looking at all the information that you need to know. I would suggest that you take out a piece of paper or open your maths book and start writing these notes, or even going back to notes that you wrote in grade 10, 11, and 12, and just adding to them. It would be so nice if you could just put all this information together, because I can tell you right now, everything that you've learned from grade 10 in trig equations plays a big role in your understanding for trig equations in grade 12. Okay, so let's look at everything that you need to know before we dive into this chapter. So there's formulas that aren't on your formula sheet. First one is this sin x squared plus cos x squared equals 1. So you need to remember that they like to rearrange this one. So all they do is just take the sin x squared over and they minus it, because you know when you move things over an equal sign, it just changes sign. Cos x squared can go over. There's it right there. So these are three very important identities. They play a big role also when we're proving identities, but we'll look at that at a different stage. The next one that's important to know is tan x is equal to sin x plus cos x. They do like to rearrange this one, but it's very uncommon. So if they had to rearrange it, it would look like this. Just moving that cos x over and multiplying it. But like I said, it's very rare that they're going to do this, but it's also just very nice just to keep in mind for those that are going to be studying further with maths at a varsity level. You can expect that from first year. Okay, then cofunctions that are important, cosec, sec, and cot. These are important again with identities. They come out of nowhere, and just learn them. Okay, so on your formula sheet, you'll get these 4 compound angles, and you'll get these 4 double angles. So these are important to know how to break them up, especially when you've got A and B that aren't singular. Same thing here if you've got like a 4 something. So we'll be looking at those deeper when we look into identities, but it's good to know them for when we doing trig equations now. Okay, so the most important thing when it comes to trig equations is the cast diagram. I don't know how your teacher has taught you to memorize this. My kids and I have a nice little one going on, but I'm not going to broadcast that. So I would like you to just, in the comment section, put your little, whatever your teacher has taught you, how to memorize the cast diagram. It'll be interesting to see what other teachers have done. But all for now, this is the cast diagram. The cast diagram is just a way to memorize what is positive, what is negative. The reason why I wrote those out is because I need to write sign there and I'm not fitting it in that small space. Okay, so this is quadrant 4. Quadrant 4 is cos's quadrant, so only cos is positive in this quadrant. Sine and tan will be negative. This is quadrant 1. This is all, so they are all positive in this quadrant. And you also got to know that in this quadrant we are going to go from 0 degrees all the way to 90 degrees, meaning this is an acute angle. This whole quadrant is classified as an acute, so our reduction formula is just theta. Okay, moving on to the next one. This is now going to be quadrant 2. Quadrant 2 is sine, so only sine is positive in this quadrant. And then this is now 180 degrees. Moving into quadrant 3, this is tan's quadrant. Tan is positive in this quadrant, only tan, so sine and cos will be negative in this quadrant. Let's go look at the reduction angles across all the quadrants. So this one is 180 minus theta, 180 plus theta, and this is now a circle, so this is going to end on 360 in quadrant 4, and this is going to be 360 minus theta. So you also get this special, let me change my color over here, I'll change it to white. You get this special reduction formula that allow you to change from cos to sine. So what you need to know is that these original reduction formula only come out of 180 and 360, just a way for you to memorize it. If we're going to be looking at 90 and I didn't write this one here, 270. These are going to come into place when we're looking at the reduction formula that change from sine to cos. So in this first quadrant, I'm going to write them in green. This is 90 minus theta. This is going to be 90 plus theta. 270 minus theta and 270 plus theta. So now these are worst case scenario reduction formulas. You don't use these unless you need to use them. The red ones are the main ones. So you would worst case scenario go and pop out one of these green ones and use it. There's one that I've forgotten here. If you're working in the fourth quadrant, you need to understand that we're always working, we'll be going clockwise or anti-clockwise this way, making it positive. But now what if your teacher decides to work it clockwise? Then what happens is, just to add here, you've got negative theta as well. But this negative theta doesn't really play a big role in trig equations, but it's just good to know that it is there. Because if we're going to be working positively, this is going to be positive angles, working negatively, negative angles. Okay, but that for now, that one's not such an important one, but we'll see what happens as we're going through. So this diagram is very important. Please make a note. I'm going to be drawing little ones on every single question that we do, or just at least on the side of the page, so we can follow it and just learn it as we're doing it. Okay, so the next thing that's extremely important is you need to know that each ratio has a restriction. So when I'm talking about ratios, I'm talking about sine, cos, and tan. They are all called ratios. And the reason why they're called a ratio is because they can actually all become fractions. So if we look at our, if we look at this that I'm drawing up here, this triangle, I'm able to pull sine, let's make this little theta, I'm able to pull fractions out of this main triangle to represent sine, to represent cos, and to represent tan. So what do we know? I've taught SOHCAHTOA. So sine is opposite over hypotenuse. Remember, opposite is always opposite the angle. So it's going to be y over r, because h is hypotenuse. And then cos theta is going to be adjacent. So if this is the opposite, then this guy over here is going to be the adjacent. So it's going to be x over r. And then tan would just be opposite over adjacent, which is just y over r. So the reason why these are called ratios is because they can all be written as a fraction. And a fraction is just another way to write a ratio. And I'm sure you picked that up while you were doing Euclidean geometry. Ratios, what r can just be written like that as well. But we'll get into that. Okay, so the reason why I have this slide here is because you need to know that with each one of these graphs, when we simplify down these equations, they need to go down to sin x or cos x or tan x. That's your end solution. You need to try and simplify these equations down to their original ratios. So what you need to know is that these original ratios actually have restrictions on the y, restrictions on this guy right here. So the highest that sine can go is 1, and the lowest that sine can go is -1, which means that if they go and say sine x is equal to 1.5, that's going to fall and it's going to be an error on the calculator. And hopefully for your case, if you are listening to this, when you are doing one of these equations, you do get kind of stressed when you see restrictions come up on your calculator, and then you think you've made a mistake. Obviously, if you know that anything greater than or equal to greater than 1 or less than -1 on a sine or a cos, if we look at that, 1, -1 is our restrictions, will pull a error on your calculator. So you can just calm down and you can be okay with that, because I know some of you guys are going to be working on these questions and it's going to do half a page of work, and then all of a sudden you've got this error that pops up on your calculator and then you're stressed. If you know that the restrictions on cos and sine is 1 and -1, you'll be okay with writing no solution. But we'll get into those as we go further into the quadratics, but we'll look at this. And then now we know tan. Tan has no restrictions on its graph. It's finished there. It just continues. It's a continuous graph. So the range on this graph is infinite. Infinite carries on forever. So there'll be no restrictions on a tan graph. What's also very important to know about these three graphs is the period. Remember, the period of each graph is one whole complete curve. And if I look at the sine graph, one whole complete curve is 360. One whole complete curve for cos, just this bowl, is 360, and tan would be 180 if you look between the asymptotes over there. So it's 90 to 270 would be 180. If you're having trouble with memorizing how these graphs look, if you look at the sine, sine starts with an S. And if we look at how this graph looks, it looks like an S. Okay, I should have just gone like that. It looks like an S. So it's just an S lying down. And the same with cos. It's just a C. It's just a C lying down. So if you have a problem with memorizing how these graphs look, there's a little key for you there. Hopefully that was helpful. Yeah, so I do feel like that's all that you need to know about these three graphs for now. So our next part 2 would be us looking at linear equations, type 1. Just a little thing. Before we start this, I just want to see, pop in the comments if you know what I'm talking about. I'm going to be mentioning a word, degree, the degree of an equation. So I want you to just go maybe research before you watch the next video. I will be explaining what the degree is, but just to give you a little up from when I start explaining it, you'll know what it means, because it does play a big role in any type of equations that you are doing throughout your whole school career, knowing what the degree of the equation is. So thank you so much for watching this video. I do hope that it was useful, and then tomorrow we'll be looking at the first type of equation. Thank you so much, guys.